Hi guys, greetings of the day. Myself Raghavendra. Today we are going with design of spur and helical gears, fifth part. In the previous part, we have seen Levy's equation for spur gear and dynamic tooth load. For this part, we'll start with design for weigh. So why it is required? So here, there are mainly two reasons for gate tooth failure. The first reason is breakage of the tooth due to static and dynamic loads. So nothing but because of FT and FD. The second one is surface destruction. So surface destruction is nothing but damaging of the surface. How it will happen? So the complete breakage of the tooth can be avoided. That is because of static and dynamic loads, whatever it is there. So that can be avoided by changing the parameters such as module or face width. But due to rolling and sliding action of the gate teeth, we will get some of the surface destruction. So which are those things we will get? The first one is abrasive wear. This is the failure due to the presence of foreign material in the lubricant that can scratch the tooth surface. So this can be avoided by proper usage of the lubricant, means there should be no foreign materials. Next one is a corrosive wear. This is a failure due to chemical reaction on the tooth surface. This one also we can reduce by making sure that whatever lubricant we will use, that will not react with the surface of the gears. Next one, pitting. It is a fatigue failure due to repeated application of stress cycles. So this is very difficult to reduce because of pitting. And the last one is scoring. It is a failure due to metal contact due to the breakdown of the oil film. This one also we can reduce by changing the lubricant at regular interval of time. But pitting is very difficult. So the failure of the gear tooth due to pitting occurs when the contact stresses between two meshing teeth, it exceeds the surface endurance strength of the material. So Buckingham analyzed the wear strength and gave an equation. So according to Buckingham, for wear strength of the gear tooth, the equation is Fw is equals to D1 small b q into k. So I am using Design Data Handbook Volume 2 by Lingaya. In that one, this equation is 23.160. So in this one, D1 is nothing but pitch diameter of pinion. Small b is nothing but face width of gear. Q is a ratio factor. It is which is equals to 2 times of Z2 divided by Z1 plus Z2. So this one also we have in the data handbook, that is equation number 23.163. In this one, Z1 is nothing but number of teeth on pinion. Z2 is nothing but number of teeth on gear. Whereas the last one, K, is nothing but, so K is a load stress factor, which is equals to 1.43 times sigma suffix FAC square into sine alpha divided by E suffix O, that is E naught. Equation number 23.161. So in this one, E naught is called as equivalent Young's modulus, which is equals to, that is E naught is equals to 2E1 E2 divided by E1 plus E2. This equation 23.162. In this one, E1 is nothing but Young's modulus of pinion. E2 is nothing but Young's modulus of gear. Alpha is nothing but the pressure angle, and sigma FAC is nothing but it is a surface fatigue strength of gear material. This can be calculated with the help of equation 2.75 times of H suffix B, HB, minus 69. So this one equation is 23.168. So HB is nothing but it is the average value of BHN for the gear pair. So by calculating all these things and substituting in this equation, we can get the value of FW. And always FW should be greater than FB. That is dynamic load. Always wear load should be greater than dynamic load. If FW is less than FD, then pinion and gear materials are not hard enough and we have to treat properly to increase the strength of that pinion and gear. This is about wear load. Then endurance strength. Next topic is endurance strength. Sometimes we have to calculate endurance strength of the gear tooth also. This one we have the equation FF is equals to sigma SF into small b into capital Y into small m. We have this equation as equation number 23.158. So in this one, b is nothing but the face width, capital Y is equals to small pi into small y, where small y is a Lewis form factor, m is a module, and sigma SF is called as endurance limit of the gear material. This one, if they are not given in the problem statement, we have to take this one from table 23.33. By substituting all these things, we can get the FF, that is endurance strength. Always this FF endurance strength should be greater than FD, that is dynamic tooth load. Next topic, selection of material. How to select a material? So the desirable properties of a gear material are, the first one is the load carrying capacity of the gear tooth depends upon the ultimate tensile or yield strength of the material. Endurance strength is the deciding factor if the gear tooth is subjected to fluctuating loads. Next, the dimensions of the gear tooth is decided by wear rating rather than strength rating in many cases, because FW should be greater than FD. So we have to go for wear rating rather than the strength rating, that is FD. Next one, for high speed, to avoid failure due to scoring, the material should have a low coefficient of friction. Next point, to minimize the amount of thermal distortion or wrapping during heat treatment process, alloy steels are preferred rather than plain carbon steel. And usually gears are made of cast iron, bronze, steel, or phenolic resins. Whereas if we want a large size gears, then that can be made usually with the help of gray cast iron. Next, design considerations. For the design of a gear drive, usually these following data will be given, that is power to be transmitted speed of pinion or gear, that is also called as speed of driver or driven gears, and center distance. So usually these three parameters will be given to design a gear drive. And while attempting the design of a gear drive, the following points should be taken into consideration. That is, the teeth must be sufficiently strong so as to withstand the static loading as well as dynamic loading on the drive. Next, the teeth should have good wear resisting properties for their long life. The drive should be compact. So we can't design a gear drive of a huge size. So we have to make how much compact it is, how much it is possible, we can make it as that much compact. Next one, the drive should be properly aligned. Next, the gears must operate without interference. The teeth must be able to resist tooth deflection, stress concentration, and accelerations. And the last one, proper lubrication arrangement should be made. For this part, this much. We'll see you in the next part. Thank you. Please subscribe my channel.